Alright guys, welcome back to my channel. Sorry for the rather long delay in between videos, but I can promise you this new series I've been working on will not disappoint. As you can tell from the video title, we are starting this build series off with a self-leveling trailer, and this will be crucial to the full project moving forward. I got this trailer from my local Northern Tool due to them running a sale, but this is the same quality type trailer that you would get from Harbor Freight or from Amazon. My first initial impressions of the trailer are surprisingly good. The one major downside is the quality of the instructions, which does kind of make it tricky to build, but since I'm planning on major modifications, I did not stress too much over the instructions. Now, just assembling a trailer straight from reading a piece of paper would be pretty boring to watch, so let's jump straight into modifying this trailer. The whole goal for this trailer is to self-level, which means the structure must be pretty beefy to handle those types of forces. This clip here shows just how much the trailer flexes, and this is just by applying a force with my hand. So to strengthen the trailer as a whole, I decided to weld all the butt joints as well as weld new members to the trailer. Here I'm starting off by adding a backbone to the trailer, which is two 2-inch angle iron pieces. The trailer was originally meant to be a folding trailer, which naturally means it's not going to be very stiff in that direction. Luckily, I remembered to use clamps and such to make my life a little easier when fitting up all these structural pieces. This last piece I needed to push out before tacking it down. So one cool trick about most wood clamps is you can flip the jaws around and create a pushing motion instead of a squeezing motion. This helped me push off the frame of the trailer and to get it mounted exactly where I wanted it before tacking it. After the two angle iron pieces down the middle were tacked in place, it was time to start working on distributing the load that the future trailer jacks would produce when auto leveling. To do this, I started breaking down my angle iron pieces into smaller sections by using a metal chop saw. After getting all the pieces cut on the saw, I went ahead and tacked them on one by one. I have since learned that I need to clean the metal way more before trying to weld, as my stick rod did not want to keep a smooth arc. But I have learned a ton, and after all, that is the goal with these projects, is to just continue to learn as much as possible. While I'm in the background doing all this welding, let's talk about what this series is going to be about and why I'm so dang excited for it. To start, I love controls and automation. I just think it's incredibly cool. And I love crawfish. So one day while cooking and eating crawfish with a couple of buddies, I came up with the idea to completely automate the entire process. And why I love this idea so much is because cooking crawfish is almost like a dark art, and there are thousands of different recommended ways to cook them. But I thought if I could automate the sequence, I could then tweak all these certain parameters and dial in the most perfect cooked crawfish every single time. And that excites me. Now that we have the structural welding done, it's time to start adding our first moving pieces into the mix. I am using 3 electric trailer jacks to perform the leveling. One at the tongue will act as both a normal trailer jack for loading and unloading the trailer, but I will also have control of it through the microcontroller. The next 2 jacks will get mounted at the rear on both sides. This will give me 3 points of contact, which in turn will create a stable and level platform. Mounting these to the trailer was pretty simple. Just cut off the existing bracket, manually jack it up to the desired height, and weld it on. You can see once I get them welded, hook them up to a power supply and do a full stroke of the jacks just to check out and make sure everything is okay after welding. While actuating these jacks, pay close attention to the frame of the trailer. You can really see how much stiffer it is compared to the clip I showed earlier. I am using a power supply so I can monitor how much current each jack is pulling. This is just to ensure that there is no mechanical bind happening. One quick paint job later, and we're ready to start wiring the trailer lights. The start of attempting to mount these lights was pretty rough. I broke a couple drill bits and didn't have the right size screws for mounting. Okay, let's try this again, but with the correct tools this time. This night, I worked my way into drilling and mounting by first laying out where I want the other lights to go, and by pulling the wire down the sides. Mounting the lights is pretty simple. First, mark the holes, then we drill the holes for screws, drill holes for wires, screw it in, and then put the lid on. Finally getting all the lights mounted without any more mishaps, it was time to move on to wiring. This was my first time ever wiring a trailer, and honestly it was very easy. For some reason I've always been scared of it and always assumed it was more difficult than this, but it was actually pretty simple. I am using a 7-pin connector with a junction box, which was a huge help with landing all the wires. I went with a 7-pin style so I could have a dedicated battery charging circuit, as well as to be able to have dedicated reverse lights. The way I'm connecting these lights to the multi-conductor cable that I ran is with these heat shrink waterproof connectors. They are the same connectors that I used on the duck house underwater lights, so I'm confident that these will stay waterproof. I am using 3/4 inch treated plywood for the deck, so after getting all the light wires ran, it was time to attach it to the frame. I did this by adding 4 bolts in each corner. In the next part of this series, when I get the tank mounted, I will add more connection points for this decking. Now that we got the main structure that this whole project will be based on, it is time to start laying out and working on the controls. The trailer leveling controls required a beefy boy power supply due to how much current each of these jacks has the potential to pull. For those curious, this is a 1200 watt 12 volt DC power supply. Each jack is rated around 25 amps, and that is a lot of current, so it moves us into the next tricky problem, and that's actual control. The main processor is a Teensy 4.0, and I really love these things, but the control voltage is at 3.3 volts. So we need a relay, but there is no relay rated for 30 amps on the contacts while only having a 3.3 volt coil. How do we fix this? Well, we just use another relay. In the industrial world, these would be called interposing relays. Let's have a look at this drawing of our system to get a little better understanding. So the Teensy is going to send its signal through this set of wires or this set of wires. And these are both a set of relays, and these are another set of relays. So in this example, we have the trailer jack set to go down. So the Teensy would send a high signal here, which will then allow 12 volts to flow through this first relay and turn on the coil of the down relay. This will allow the 12 volts to flow through the set of contacts over and then into the motor negative, and then the motor positive would go back to the ground of the system. Here's a quick look at all 4 states. Feel free to pause the video to study the drawing further. The first thing we must do is disassemble the plastic housing, starting with the tongue jack. This is the only one that's different in that it needs to be able to be controlled from the battery or from the controller. I am again using these waterproof connectors for all the wire splicing. And after doing all the planning work, making these drawings, it was just as simple as connecting the wires per the drawing. These were much simpler in terms of wiring, so let's talk about how we know the position of the jack. We are doing this by using an optical encoder, which all it does is send out evenly spaced pulses while the shaft rotates. So all we need to do is count every pulse and then convert it from pulses to inches. And we do this by using interrupts on the Teensy, that way we don't miss any of the pulses and we get a very accurate count. After finishing up the last little bit of testing with the program, I was ready to start measuring what the encoder pulse to inch ratio would be. I did this by running all the jacks for several inches and then physically measuring the travel. Comparing that value to the pulses captured by the Teensy, I came up with an average conversion constant of 1/10,000th inches per pulse. Last quick item to complete is to laser on a Nate Makes logo on the back. I thought this would be a cool spot, and it would be a great demonstration of just how large this Creality Falcon 2 laser can burn. After getting the program set using Lightburn, I adjusted the laser to the right height. With the feet being adjustable, it really speeds this process up. After measuring it for center, I used the provided height gauge tool to set the head of the laser. The air pump is surprisingly quiet. With the dampening feet Creality put on the bottom, it really does a good job of being silent. I also like that they give the option to control the airflow going to the nozzle. On the Creality Falcon 2, they also give you various ways to run a program, whether through SD card for batching or through the USB cable from your computer. Now for the satisfying time lapse. Last thing to mention is Creality included multiple safety features to stop the laser. I really like the touch and feel of this e-stop. Alright, I'm going to do a little demonstration of the trailer setup. So, first thing we're going to do is unload the trailer, and that's going to be using the toggle switch in battery mode. So we'll be able to lift and lower the trailer from my hand toggle switch. As you can see, the trailer is now lifted. Okay, and then now what we would do is we would put the this is the tongue jack. We'd put the tongue jack in auto mode. This is now going to allow us to control everything from the PLC. And then one thing I would have to do currently is plug it in with power each time. All right, we now got the 120 plugged up. Now this trailer should be ready for auto mode. Right now I'm using my laptop, but there is an option in the future where I will have a nice touchscreen HMI in the back where all of the controls and graphics will be displayed. This is made by Electro. It's 11.5-inch touchscreen. I've been very impressed with it so far. Just don't have all the graphics made for it just yet. But as you can see, each jack has an optical encoder, so we know where the jacks are at all times. That goes for all of them. The only one we have manual control of is the tongue jack. All right, so when I put it in auto mode, you should see some of these relays turn on. The jacks will start moving. You can see that the trailer is not level, so the back should come up. And our IMU values are currently -6 and -3. So it's definitely going to want to pick it up, and it's going to want to tilt it some. So if we just type in an A into here, now eventually that's going to be on the touch panel, but this is what we have right now. We have relays turning on. Operator side jack is moving, as well as the drive side jack. Now over here, these are our encoder values in inches. So we know that both trailers are lifting in a positive direction. All right, so the biggest problem I'm having is this is our IMU unit here. And I don't really have it mounted securely, so it's wanting to want to move on me. You can see, got this axis level. Now it's working on this axis, and it thinks that's level. And there we go. It's pretty level. You can see, so my biggest problem for sure is this is our accelerometer unit. It's a B&O 055. And I have it mounted by tape, so it's definitely not mounted in the best way possible, but this is just for testing and proof of concept. But you can see it picked the trailer up. It's now level in both axes. All the weight's on all three jacks, so it's very stable. So then now we would do the crawfish boil and all that. And let's say we're all done. Now we need to get everything back to load the trailer. So what we would do that is, in this case, we're going to place a Z here for 0, which is going to tell the jacks to go back to their 0 position. Because remember, each of these encoders is counting all the revolutions, so we know exactly where they are. Matter of fact, we know that they both extended roughly 12 inches. The other one's 0 because we never really moved this one. Because the way we're doing the leveling is we're using our tongue as a reference and bringing everything up to the tongue. Let's type the Z in and set her back down to normal. We can see here, we got 2 trailer jacks turned on, and it's both at the down position. And then we're gonna work their way back down. There we go, perfectly back to 0. So now we'd be able to load the trailer, which, let me back the truck up and we can go through the loading process. The trailer loaded for demonstration purposes. Front jack is all the way up. These jacks were commanded to come to 0, so they're all the way up. So in the next video, we're going to mount the tank. And this is going to be the tank that will cook and purge and all the good stuff to the crawfish. So the goal for the next video is mounting the tank somewhere in this area. We're going to insert a water line somewhere in this area. We'll automatically be able to purge the crawfish and get them all cleaned out. We're going to do this by building a couple flow control valves, a couple turbidity sensors on the outside. But yeah, the next video should be pretty sweet.